Thank you for stopping by. I am Barb Mays-Bousted from the National Weather Service's Warning Decision Training Division, working with Victor Gensini from Northern Illinois University. We'd like to take you back to August 28, 1884 in eastern South Dakota, or Dakota Territory at the time. Many of you likely have seen this photograph before. Often misidentified as the first surviving photograph of a tornado, it actually is the second known photograph, and it was taken on August 28, 1884, near Howard, South Dakota. Some have speculated that the photo is a fake, but evidence shows that it was only lightly retouched, and the retouching occurred in the parent cloud, not the unusual three-funnel appearance. A sketch by one J.H. Knott of a tornado near Redstone, South Dakota, on the same day, which has been reprinted in several publications, shares this unusual multi-funnel appearance. At least 5 significant tornadoes occurred on August 28th, causing at least 7 known fatalities, along with livestock losses and property damage. Adding evidence to the unusual shape of the tornadoes, Laura Ingalls Wilder's account of a tornado encounter in her book These Happy Golden Years further reinforces a multi-funneled appearance. She and her fiancé, Almanzo Wilder, took a buggy ride southwest of their homes in De Smet, South Dakota that afternoon and observed a tornado. In her words, a second point came groping down behind the first, then another. All 3 reached and withdrew and reached again, down from the writhing clouds. She also noted that the storm was coming toward them from the northwest. We're going to focus on this multi-county portion of eastern South Dakota. Note that De Smet, where Laura and Almanzo originated their buggy ride, is marked with a red star. Snow in 1984 produced a replica of some of the tornado tracks observed on August 28th. We also know that one additional significant tornado went through Sioux Falls, South Dakota. We used the 20th Century Reanalysis version 3 to force the initial and lateral boundary conditions of the WRF model to produce a Day 2 reforecast of the event, as if it was issued on August 27th at 18Z. Our goal was to see if the WRF, forced by this reanalysis, could replicate the placement, structure, and timing of the convection. We also wanted to more closely analyze the mesoscale environment of the outbreak. The model indeed produced a convective outbreak in eastern South Dakota in the afternoon on August 28, 1884. Let's start by looking at the morning surface observations available from the NOAA Daily Map Library. A surface low was centered in northeastern North Dakota, with a cold front extending southward through the central Dakotas into central Nebraska. The model replicates the surface low and associated boundary, noting a moisture gradient across the boundary as well. By afternoon, the low had progressed into western Minnesota, dragging its trailing boundary into eastern South Dakota. It does appear that low-level moisture had increased behind the boundary as well. Let's take a closer look at the mesoscale environment forecast for the afternoon. The post-frontal sounding on the left exhibits 3,100 joules per kilogram of surface-based CAPE with a backing wind profile and with a relatively high LCL. Ahead of the front, surface-based CAPE reached 4,100 joules per kilogram with a less dry low-level thermodynamic profile and a less elongated hodograph. The low-level moisture ahead of the front does influence the sounding, with a lower LCL ahead of the front than behind, and with higher low-level dew points. Shear profiles in both cases are not classic tornado-producing environments, which leads us to believe that tornado initiation likely was enhanced with the ambient vorticity near or just behind the boundary itself, with storms likely following right-moving supercell vectors. Southeasterly motion in these environments would enhance the low-level storm relative helicity, again increasing the tornado potential. We are just beginning to explore this tornado outbreak in the model realm, and we'll have more results as we continue. This particular well-known tornado outbreak is steeped in history and literature, and our emerging ability to run a reforecast model to understand its science helps us understand this event scientifically as well and place it in context. Thanks for stopping by, and please let us know if you have any questions.